Hi everyone, I hope you're okay. This is video number 8, guys, which simply means I'm doing question 8 from the 2022 November mathematics paper 1 examination. Please note that there are already 7 videos uploaded before this one, and there will be the other 2 videos that will follow this one. Just stay tuned, guys. You can click the link on the description below. It will take you to the playlist on whereby you can find the full memorandum, and then you can download the question paper, answer the questions with me. If there are things you're not sure about, please do say something on the comment section. I'll come to you. Okay, I'm given the graph of y, which is the derivative of f, and I'm told that that graph is drawn below. That graph passes points P, Q, and R. I'm supposed to determine the values of m, n, and k. Basically, I'm supposed to find the equation of the derivative function. Okay, since I'm given the x-intercept, right, I'll find the equation of my derivative function by using this formula that says a x minus p multiplied by x minus q, where both p and q represent my x-intercept, right? In this case, my x-intercepts are negative 1 over 3. Since the 1 over 3 is negative, I'll write it as plus 1 over 3. And then since the q is positive 1, I'll simply write it as minus 1. So the only thing I need to find now is the numerical value of a. I can only find the numerical value of a by substituting any point on the curve of the derivative function. I do have point r. Are we together? Point r simply says y is equal to 1 if and only if x is 0. So I'll have a 1 this side. I'll have a multiplied by a negative 1 over 3. You can divide both sides by negative 1 over 3. You'll simply have a is equal to a negative 3, right? So this simply means that f prime of x is equal to negative 3 x plus 1 over 3 times negative 1. Yeah? Then I still have a negative 3 outside the bracket. I'll just expand my bracket. I'll have x squared minus x plus 1 over 3x minus 1. Minus 1 over 3 rather, excuse me. And then this is negative 3 multiplied by x squared minus 2 over 3x minus 1 over 3, right? So therefore, for me to find the graph of f, I must just multiply everything by the negative 3 there. So I'll simply have negative 3x squared plus 2x plus 1. Are we together? So this simply means that the value of m is negative 3, the value of n is 2, and the value of k is equal to 1. Are we together? Yeah, so I'm done with that. Then second question, I'm given the original equation, right, of f of x, and I'm supposed to determine the coordinates of the turning point. Okay, remember that whenever you're given the derivative function, your x-intercepts will always tell you about the coordinates of your turning point. Your x-intercept will always tell you about the coordinates of the turning point, right? Okay, so I know the x coordinates at my turning point. I have negative 1 over 3, and the other turning point I have positive 1 as my x value. Are we together? So whenever I substitute I'll simply get 49 over 27 here, 49 over 27, and for this one I'll get a 3. Are we together? And then now I'm supposed to draw the graph of f and indicate and I must indicate the turning point and the intercept with the axis. Okay, I know this is my y-intercept. I do have the turning point. The only things I'm short of is the x-intercept. Okay, for me to find x-intercept, I need to take the graph of f of x and equate it to 0, then solve x. I'll simply have negative x cubed plus x squared plus x plus 2 this is equal to 0, right? For me to solve x, I need the unknown with the highest power of x to be positive, no? So I must divide everything by negative. I'll have x cubed minus x squared minus x minus 2 is equal to 0. I just need to find a factor here and then factorize. And then factorize, ne? The factor that I'll have is 2 cubed. Let me check. I'm doing trial and error, ne, guys? Please do it on your own as well to find the factor. Okay. So my factor is x minus 2. For me to find the trinomial that will get in the other bracket, for the first term and the last term is easy. For me to find the first term, I just need to square the first term over here, or all I need to do is to say this term divided by this one. I'll simply get x squared, and to find the last term, I'll say negative 2 divided by this negative 2. This will give me plus 1, yeah? Okay, and then for me to find the middle term, I just need to say minus x squared minus the product of this. Are you together? I simply have to say, let's call this value m, né? For me to find m, I just need to say minus x squared, negative x squared minus the product of negative 2 times x squared, which is just negative 2m x squared, né? So this will give me negative x squared plus 2x squared. I'll be left with x squared, né? Yes, I do have x squared. However, I will just write x la, because when I multiply by this x, I will get that x squared. Okay. Okay, now I do have my polynomial factorized. I know that here there are no real values. There are no real roots, né? Let me just say in this bracket there are no solutions. Or rather say x is equal to 2, and then here x squared plus x plus 1 equal to 0. I will have no solution. I'll have no solution there, né? So I only have one x-intercept. I'm supposed to draw my graph. The value of a is negative. Okay, so my graph has to look like this. Has to look like that, né? 49 over 27 is a number which is less than less than 2. Okay, so my graph will be like this, guys. I'll simply have my turning point. I'll simply have my turning point here on this line, and the other turning point has to be there on that line, eh? But my graph will not look good, because that's a big space over there. It's a big space for my liking. So I'll just draw my axis over there. I know that I have my graph is supposed to look like this. It has a turning point there, another turning point, and then come and cut over here, né? The y-intercept is 2. This is the y-intercept. The turning point, I have negative 1 over 3 and 49 over 27. And then the other one, I have 1 and 3. And then my x-intercept is 2. That's how your graph should look like. Okay, and then now I'm told that points E and W are two variable points on f prime of x. And are on the same horizontal line. H is the tangent of f prime of x at point E. G is the tangent of f prime of x at point W. H and G intersect one another, excuse me, at point D. Okay, let us illustrate this information. You have two tangents. Let's say the tangents, we have 2 points there, né? It's E and W. These tangents, they move like this. Other one moves like this, and the other one will move like that, né? Please note that, guys, these two tangents will meet at point D. Let's say this is point D over here. Are we together? And since they are on the same horizontal line, that means point D is a point where the derivative function is symmetrical. So point D is vertically above the turning point of the derivative graph. If I can find the x value at the turning point, I can simply find the value of A. Are we together? I can simply find the value of A. How can I find the x value at the turning point of my derivative graph? The x value of the turning point, I can say 1 plus a negative 1 over 3 all over 2. What do we get? 1 plus a negative 1 over 3 all over 2. We'll simply get 1 over 3. Are we together? We'll simply get 1 over 3, because whenever you find the x value turning point, you must find the average of your x-intercepts. So the x value on this line, on this vertical line over here, x is equal to 1 over 3. Are you together? So the value of A, that's why it's even 1 mark. The value of A is 1 over 3. Né? Now I'm supposed to determine the values of B for which H and G will no longer be tangents to the curve. Okay, let me find the corresponding Y value here at the turning point. Né? Let's say this is point P. Point P, my equation of the turning point, I have negative 3. The x value is just 1 over 3, right? Squared plus 2, 1 over 3 plus 1. So the corresponding y value over here, guys, the x value is 1 over 3, corresponding y value is 4 over 3, right? Okay, so now if these two graphs H and G are no longer tangent, it simply means that the graphs can meet anywhere. They can meet either here or there. Are you together? Just note that they will meet anywhere, but it will be below the turning point of the derivative function. So since we are dealing with the variable points E and W, it simply means that the value of B can be anything which is less than 4 over 3. Are you together? So that's how, guys, we would have tackled question 8, and I really hope that, guys, the video helped you out. If there are things I'm not sure about, do write on the comment section. I will come and explain.